Hey students, welcome to the week, and I wanted to go over the homework from last week, kind of give you detailed step-by-step on how you would complete the homework. We also are preparing for an exam, so this is a great time to make sure that you really follow how each of these things are calculated and what you can learn from each of the pieces. Now, one of the important things I would share here is that this is an analysis of output. And you have output decisions. In any business, you could say, I want to stock this land at a higher rate. In any farming operation, you could say, I want to try to achieve higher yields. These are all decisions on how much output do you want to try to go for. And every time you say, I want to produce more, you just inherently know you're going to have to spend more, invest more. You've got to put more into it. And so in this example here, we have decisions in our example of feeder calf alternatives. We're doing a custom feeding business. We're going to feed these cattle in a really certain specific way. We have maybe a grass combination grain, whatever it is, it really doesn't matter. We just have decisions, and it could be almost nothing, 2 feeder calves out there. Or we could push it higher and go all the way to possibly 28 feeder calves out there. But every time we do that, we're going to have to feed more and invest more. And then there's really the decision that we're after here. How do we know how much to produce? Well, how much you produce or how much you go for depends on really 2 important things. You can't just have one without the other. One of those is, what does the cost look like? And sometimes we focus on cost quite a bit. In fact, sometimes cost is even viewed as the most important part, but it's only half. The other part of the equation that we need is the revenue, how much money we're going to make. Because if I can change my investment by, let's say, $1,000, that seems like a lot of money to have to invest to go to a little bit higher level. But if my product's worth $1,400, you would do that over and over and over again. In fact, that's the whole really outcome of this analysis is the change in the cost that you have is one way we can look at it, which is what we do here. The change in the cost is a great way to measure how much it costs more if you go to the next level. But then the question is, well, what's the revenue change by? And you have to have both those pieces. You can also look at things in total cost perspective. So how much is my total cost? And then how much is my total revenue? But average or total analysis is one thing. Marginal analysis, measuring the change, that's another. And so that's really what this homework does, is kind of focuses on the marginal change, because that's really the more superior way to look at decisions. Because we know where we are today, we want to know, we know where we want to go, and then if we know how much that cost and how much that's worth, it's better to look at what's the change worth, because otherwise stay where you are. So marginal analysis is the measure of change. That's what marginal means, change. And in this homework, that's kind of the focus. Don't get confused and think this is about total analysis, because really the last 2 columns you can see here are marginal analysis. All right, so that's kind of just an overall thing about what I hope you get out of this. Let's go through and see how the numbers are calculated so we can then answer the questions and go ahead and emphasize these things I'm talking about. So let's take a look. All right, you can see here we've got our calf decisions. We can put 2 out here, 4 out here, 6 out here, 8 out here, make it simple. It goes up by 2 every time. So every decision is a change of 2. You got fixed costs that are related, so that's like the pens, depreciation, insurance, stuff that's not going to change. You put 2 out there, you got the same cost. You put 28 out there, you got the same cost. Variable cost is the one that changes. So you can see as you put more cattle out there, your costs just continue to go up. They never go down. Total cost is just adding those together, so pretty easy. First thing you do when you get to a problem like this is fill out the table. Don't try to worry about these questions just yet. Fill out the table. Average is a pretty simple thing. Average always means you divide by something. So you're dividing fixed cost. I'm going to write a formula, equals, divided by that calf alternative right there. That's $32.50. So each one of these calves has a fixed cost of $32.50. Now, as you keep producing here, this keeps going all the way down. I'm not going to do that. I'm going to choose copy, long way to do it, and cover all of these and choose paste. And it just repeats my formulas all the way down. You can see what it does. It changed the cells as I went down the row. So Excel's a quick way to handle these things. You can do it on a calculator as well. All right, so that's the average fixed cost. Now you can see it starts off high and it gets down lower and lower, and that's because it's a fixed number with output going up. Now, this is stage 2 of production. It's dang sure not stage 3 where production goes down. That's a irrational stage that we talked about in the last input decisions. But output is, you've got it here. All right, so there we go. Those are our alternatives. We could put lots of calves out there, but we decide to stick with either 2 to 28, and your fixed cost gets cheaper and cheaper as you go. In fact, fixed cost, another word for that, is a sunk cost. Sometimes it's called that. It's a sunk cost. Spell cost right. Still not spelling it right. There we go. It's a sunk cost, and that sunk cost is just a great way to describe that it's kind of sunk. There's nothing you can do about it. One thing about fixed cost is it just gets cheaper and cheaper and cheaper, and that is the example of economies of scale. Economies of scale means the larger we are as a business, the more efficient we are on cost. And so some of the things that are important to look at here are that economies of scale is really focused on the sunk cost area. There's not a whole lot of economies of scale here in average variable cost, but let's see what they are. So equals total variable cost divided by the quantity again, and then I've already got that formula. If I use this little plus key, it'll copy paste all the way down really fast. So there we have those. Well, you can see that average variable starts off at 900. It drops down. So we're getting a little more efficient here. Keeps going down. Keeps going down. All of a sudden there it starts to go up. Now you might say to yourselves, well, hold on. If that's where my costs start going up, I would stop. But that's a mistake. That's looking at only one side of the two variables needed. I need cost and I need revenue. So at this point, when you're looking at cost, you're just talking about what does it cost? You're talking about maybe the efficiencies of our operation a little bit. Yeah, things are cheaper here. Things get more expensive here. But if I'm getting more revenue, then I might want to keep pushing forward because I am getting a larger quantity here. I'm achieving more output, and more output's going to give me more revenue. I'm really focused on having as much revenue as possible with as least cost as possible. And that difference is called profit. And that's really where you start to look at it. But right here, all I know is what it cost me. So that's really all I'm looking at is some kind of efficiency maybe. Cost me a little more, or cost me a little less, cost me a little less, it cost me even less. Now it costs me a little more. Now it costs me a little more. I'm just understanding what my costs are. So you do have a little bit of economies of scale happening throughout here, but it's usually at a pretty low level because variable cost is going to change as you produce more. So typically you're going to end up in some of these areas to try to find profit, but we don't know yet. Okay, average total cost. Same idea. Take total cost, all the costs now. Forget fixed and variable, and run those across there. So if you were looking at selling about 10 head of your operation, let me highlight 10 right there. Let me highlight 10. There we go. Highlighting 10. 1370 is what the total cost is per animal. The average is like a total, right? It's at a particular level at 10. It's 1370. If you were selling the cattle at 1400, it's obvious that we have more revenue than cost, and so we would be making money right here. So if I ask you about what the profit is if you produce at the 10 head level, it's per head 1370, 1400 minus 1370, so that would be a $30 profit per head. Now, one thing I can share with you is this whole table right here, this side right here, these total values, they are for each of the levels. So for example, 10 heads going to cost you $13,700. 18 heads going to cost you $22,500. The rest of these variables all across here, the ones you calculate, are all based on per unit of output. So each of these are per unit of output. In fact, if I maybe kind of highlight this a little bit here, and so that's all per unit of output. If I run across here, these are all per unit of output. Now that's important because we want to know what is our unit. That is important. What is the, can't type is, what is the unit? And the example of the unit here is per head. So it's important when you do these problems to realize what the unit is, and that's number of feeder calves per head, or I should say probably the number of feeder calves. But it's not the number of feeder calves. I said that wrong. It is one feeder calf because everything is the base of 1. So that is what this whole table is based off of, 1. So if you know 1 cost you $13.70 and their 1 sells for $14.00 to get processed and sold as a side or as a whole animal to be eaten, that $14.00 minus $13.70 gives you that profit. All right, so that is what we call average. And average tells you things like at a particular level. In fact, variable cost is one that we must cover. That is important to also have here. We've got to cover variable cost. Because if you don't produce any calves at all, in other words, if we don't have any calves on feed, then we would incur fixed cost. So there's nothing we can do about that sunk cost. Remember that, per head. But if we decide to get up off the couch, let's go with 10 head again. If we decide to get up off the couch and produce, there's going to be an extra $720 that comes to you. You better earn more than $720 or it wasn't worth it. So if the calves are bringing $800, $900, that's definitely not going to cover our total cost, but it would cover the variable, so we would take it for a short period of time. That's better than just taking $650 in cost, because if you got $900, you'd lose money, obviously. But if you got $900, you would be making $80 above your variable cost. That $80 could get contributed to the $650 and make it be less expensive, so you would actually be better off financially. But if you can't cover average variable cost, then you should not be producing at all, because you're just adding extra cost. You're already going to lose this one, but you're going to lose even more if you cannot cover that. So the minimum price is going to always be average variable cost. So I'm going to put that down here. So that is the minimum price always. In every one of these tables we do, that's the minimum price. The total cost is your break-even price, because that way you know what your cost and your revenue equal together would be. So you wouldn't make any money, you'd break even. You at least need to cover this if you're going to produce, and economies of scale is where you really see fixed costs, but it's a sunk cost. It's not as important to look at per unit. These two are the ones that you're going to be looking at. All right, now this is all average analysis. What about marginal analysis? That's a better way. I can talk about each one of these levels, but marginal analysis kind of focuses on what happens if you make these decisions to change. So I'm going to mark out those first two. Okay, they are marked out here. That's what the X's across that mean. I'm not going to worry about that. Now I'm going to write a formula here, equals. What does my cost change by? Well, it goes from 9,800 from the 8,300. So I go ahead and close my parentheses. That's the change in cost divided by the change in production. And of course, all of these are going to be minus each other, which is going to be 2 every time. So when we divide this out, it costs you $750 per head to go from 2 to 4. Well, what's the marginal revenue from 2 to 4? What's the revenue changed by per head? It's just going to be that same number right there. So I'm just going to press equals, stick that number right there. And that is that one. In fact, I'm going to press equals and choose it again, and I'm just going to bring it all the way down, because that is the, what's happening here with my computer running slow? That is the change in revenue. Every time you sell one more, you get $1,400, because that's the price. So margin revenue is actually pretty easy. It's not much of a column to calculate. This one is looking at the change in cost every time you move. Well, once I go to the second row, it represents both of these rows. So that's the 2 to 4, $750 per head. Now, if I just copy that formula all the way down, I want to let me do this. It's trying to move it on me. So just copy and paste. Now, that is what the cost changes by. So if you go from 2 to 4, it costs you $750 per head, but you get $1,400, so you would do it. So the answer is yes, I would do that. All right, next decision. It costs you now $800 per head to go from 4 to 6, but you would still get $1,400. I'd do it. Next one is great. It costs you even less. It costs you only $650 to go to this next one. Still get $1,400. I would do it. These are all individual decisions. This is not total analysis. This is the value of the change, and that is important to see right there on the top of this thing here. All right, so let's keep going. Next one is it's even better. Each one costs you $500. So the answer is yes, you do it because you're getting $1,400 for each one. So it's the change in the money in your pocket. You make the decision to produce more, your costs go down. Now that happens for a couple of reasons. One is that's when our variable costs drop and our fixed cost is still dropping. And so that's a pretty good decision. Now the next move is a different deal. To go from 10 to 12, to go from 10 to 12, it cost you $1,000 per head to do that. Now would you do it? Your cost jumped up. Sometimes everyone will stop and say, whoa, if my cost goes up, I don't want to go anymore. That's because you're thinking of it like total. This is not total. This is marginal. So the answer is, if I can take $1,000 out of my pocket and spend it per head to get me to that 12 level, on average, for that 10 to 12 move, cost me $1,000. If they're going to put $1,400 back in my pocket, the answer is still yes. Next one, it goes up a little bit more, $1,050, still get $1,400. The answer is yes. Next one goes to $1,250. Again, $1,250 out of my pocket. You're like, oh man, why wouldn't you stop way up here? Trouble is, up here is only 10 head. I am actually going down here to $1,250. I'm at 16 head. I got 6 extra head that I am selling at $1,400 a piece, and they cost me on average $1,250. You keep doing it because that's making your overall profit go up. This is marginal analysis. It's just the value of the, just the value of the change. All right, next one. 1,100 to 1,400. There we go. That's a yes again. In fact, my cost even goes down there a little bit based on variable cost moves. So maybe I got to a higher level of feed buying and I end up with a little more efficient feed price. However, you go to the next level and it costs you $1,500. And so this is the no spot. We would not go there. However, the answer is somewhere between 18 and 20. So let me kind of try to highlight that area of the green money spot. That's where the answer is. Because if I'm spending $1,100 and I get $1,400 back, I'm going to want to go to that next level. But if I go all the way to that next level, 20 head, I'm at $1,500 and I'm only getting $1,400 back. I'm losing $100 there. I would not do this, but I would not stop here. So the answer is somewhere between here. Maybe it's 19. Maybe it's 18, and then I have a head in there that I actually get sold a little earlier. That is analysis that's going to require further investigation. However, it does push us to look for the higher production possible as long as we're handling our change in cost. And that's what this is really all about, is getting to these two numbers. Understanding this change is able to be understood through the cost analysis part. So that's kind of what we're trying to look for here. Now that we've got this table done, and hopefully these answers get really easy. What is the break-even price if you're doing 16 head? Well, if I'm at 16 head, break-even, remember that is total cost. So break-even at 16 head is equals, that's 16 right there. Break-even is 12. Let's see, what would that be? Let me open it up a bit. $1268.75 per head. What about the minimum price? Equals at 16 production level. The minimum is going to have to be covering our variable. So we've got to get $862.50 for them. That's your break even. All right. What if you decide to go from 14 to 16 head? Now, when I say additional here, I hope you follow, that is change. Same thing. So the additional cost to go from 14 to 16 head is equals 14 to 16. Move across here. Additional is marginal, and it's right there at $12.50. So it costs you $12.50 to go to that. All right, next question. What is the additional revenue added? Well, that's marginal revenue because that's the change in revenue. And that's actually pretty easy because that is the same all the way down. Because remember, this whole part of the table is all valued per unit of output. So that's per head in this case. All right. So additional revenue is the $1,400. The additional cost going from 14 to 16 is $12.50. I'm kind of trying to focus on to you right there that, hey, this is still a yes. We go to the next level, it even becomes a better yes, and then we go to the next level and it's a problem. So what is the level that illustrates maximum profit? And you would say it is 18 to 20 head. And then the answer for why? No answer for that is because marginal revenue equals marginal cost, somewhere between those decisions. And that's probably a good way to say that, decisions. I guess that's right. All right, so that's a good way to say it. All right, so there is your homework for this week, or this prior week, and this is a very good review of this content as well. So hopefully it's something you can use to help you better understand the information. Take your homework that you submitted and make sure that it relates to this. If it does and you understand these things, then you're in great shape as we talk about an exam. But it kind of wraps up this section. There's also some other information here in the week that just introduces a little bit of what marginal cost is good for. As you can tell in this whole table, really marginal revenue is pretty easy. It's given to you. Really all the other costs are just descriptive for you. It's the marginal cost that helps us make the yes decision in that column. So that's something you can use to hopefully help follow in the next section. A few new things to talk about, and then make sure you look at the entire week and what is due and what's happening so that you can be ready. But I hope this video helps you look at, again, last week's homework. Thanks.